Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris bin Zamri and my number metric is BE101031. Alright, for today I will present a group 4 appendix A problem. Alright, for the group 4, for the question 1 is it gives a current 9 micro inductor and the current in the equation of current. And for the question 1A, it has to plot a graph of current versus time at MATLAB. Alright, I will already done it coding and I use a SimST and the equation current I already defined it. So for the same state is to define a variable t, and then I use a f plot f0 until 5 for plot current versus time, and it title current versus time. Alright, and then when I press a run, it will show you a graph of the current versus time. So this is a graph for the current versus time. You can see it times at 5 and the current at maximum is 0.45. And then we go to the question 1b. Alright, the question 1b, it has to find the voltage across as a function of time and plot a graph of the voltage versus time and calculate the voltage value when t equal to 5 ms. Alright, so it has to find a voltage first. So when it gives a inductor and current, so for the formula for find the voltage is inductor L times differential current. So this is a coding for the voltage seems T and the equation current, and then I define a value of inductor 0.00009 is equal to 9 micro. So I put at this coding L times differential equation of the current. Then I use a F plot V and 0 until 5 e times, and the title is voltage versus time. And then I press a run to show the graph of voltage versus time. So this is a graph voltage versus time. You can see time is at maximum is 5 and voltage is at maximum is 3.5 times 10 negative 5. And then it asks to find a voltage at t when t 0.005 equals to 5 ms. And then I run to show at here when t equal to 5 0.005, and the voltage will become a 3.5 to 712 e negative 0.5. And then if you want to coding the question for the when t equal to 0.005, yeah, you have to use at common window, and this is my coding. So the output will become like a graph I show you before. So this is the output 3.5 to 71 e negative 0.5. Alright, and then we go to question 1c. For the question 1c, it has to find the power and plot a graph of the power versus time and determine the power when t equal to 0.4 second. Alright, so for this I already done it coding, and it use a sims t v and I define a voltage equation, and then I use a equation I because the formula for to find the power is V times I, and then I use a f plot power 0 until 5 e times, and the title is power versus time. And then I press run to show graph power versus time. This is it's time 5 and the maximum for the power 6 times 10 negative 6. And then it asks to find when t equal to 0.4 second. So I press run to see it at graph, and I will get this when the time 0.4 and the power will become a negative 2.07x73 e negative 0.6. So if you want to coding the equation when t equal to 0.4, it like this. I already done it, and I put at common window, and it will show output same as like I show you at voltage at graph. This is output negative 2.0787 negative 06.
My name is Wanafis bin Abghani. My numeric is BE101079. Okay, I will present for the manual calculation for question 1 and question 2. Okay, first we go to the question 1. Okay, for the question 1b, we need to find voltage across as a function of time, and we need to calculate the value voltage when time equal to 5 millisecond. So to find voltage, we multiply the inductor and the I given the time hyperbolic 40, and we differentiate the time hyperbolic 40 and we get sec hyperbolic square 40. So we multiply 9 micro multiplied by 4 sec hyperbolic square 40, and we get 36 micro sec square 40. So when the value of voltage when t equal to ms, we substitute t at this 5 milli, and we get 35.78 micro, and we can see that we get the same answer for the MATLAB question. We get same answer lah. Okay, so next we go to the question 1c. Find the power and determine the power when t equal to 0.4 second. So we use the formula of PVI, and we get the V and I is this is there and is there, and we just multiply it and we get this. And to find t equal to 0.4, we substitute we substitute 0.4 at t, and we get negative 2.08 microwatt, and we can see that we can get the same answer for the MATLAB question.
For the question 2, it gives a 3 amp capacitor and the equation of current. Alright, for the question 2a, it asks to plot a graph of the current versus time. So I already done it equation for encoding for the question 2a. So I use a since t to define a variable t and equation current, and then I use a fplot f05 to plot a graph of the current versus time, and then I press run to show a graph current versus time. So this is a graph for the current versus time. Current maximum is 100 here, and then times at 5. And then we go to question 2b. It asks to find the voltage across as a function of time and plot a graph of the voltage versus time and calculate the voltage value after t equal to 0.4 ms. So I can use 0.5 ms because it has after t equal to 0.4 ms. So I already done it coding, and this is a coding for the question 2b. This is a equation for current and a value of capacitance 0.003. And then for the formula for to find the voltage when it gives a capacitor and current, the formula for to find the voltage is 1 over c times integrate exponent integrate current, and then to plot the graph I use fplot b05 times, and the title is voltage versus time, and then I press a run to show graph of voltage versus time, and the graph voltage when the maximum is 14,000 and times at 5. So it asks to when t after t 0.4 ms. So I use this 0.05 to plot a graph here. So this when times at after 0.005, the voltage will be a negative 99.9875. And then if you want to coordinate, I already done it, so it will be like this. So it will show you same output voltage at what I showed you before at graph. So we go through question 2c. It asks to find the energy and plot a graph of the energy versus time and determine the energy stored at time t equal to 5 seconds. Alright, I already done it to the coding. Let me show you this coding. I put again coding of voltage and capacitor and the value of capacitor, and for the formula energy is 1 over 2 times C V power of 2. So I put this is coding for the formula energy, and this F plot energy 05 is to plot a graph, and then the title is energy versus time. Then I press a run, it will show you a graph, this one. So you can see it, energy 3 times 10 5, and the times at 5. And then it asks when the energy stored at times t equal to 5. So this is 5. So as you can see, I just put it here. So the energy will be a 315019. So it will show you same according. I will show you this. So it will show you the same output at energy 3.1502 E plus 05, same like this here, 315019. So that's all for.
Okay, next we go to the question 2 for the manual calculation. Okay, so for the question 2b, we need to find the voltage across as a function of time, and we need to find the voltage value after t equal to 0.4 millisecond. So we use the integration technique for this question, and after that we use 1 over c integrate it is exponent t sine 3t, and after we calculate it, and we get negative 99.49964. So for the MATLAB equation, we get the near value for the answer for this question. And then for the question 2c, we need to find the energy and determine the energy stored at time in 5 seconds. So we use the formula E equal to 1 over 2 CV square. So when we substitute the value of CV C, and V the power of square, and the answer we get is 315,018.86738. So for the MATLAB equation, we get this. It is the same answer, and it is look different because it is 3.1502 uh, times the power of 5, and it is the same answer.